What we're looking for here is the cost of Mighty to be equal to the cost of No Shrink. So I'm going to bring both of these individual parts and set them equal to each other. So I will have 49 plus N is equal to 4.5N. All right, so remember that this actually has a 1 in front of it for this N here. Okay, so I need to get those together. Now we're learning more about this in the future as well, but I'm going to show you this setup. I want to get all the numbers with the variables and coefficients to one side. So I'm going to look to move this over. So if I'm going to do minus 1 in here and minus 1.0 in here, to be very careful to line up those decimal points. And in this case, this is going to be gone. 49 is equal to, this is going to be 4.5 minus 1, which will be a 3.5n in that case. So now what we're going to do is I need to do that division as well. So I'm going to divide by 3.5 here, divide by 3.5 here. It's going to be a big 1n. So then I'm going to actually need to do 490 divided by 3.5 or 35. So I'm going to do that swoop here. Remember how we need to move that one swoop over here? So I'm going to add a 0. So I'll do 35 times this. So if I put this in here, 35 goes into 49 one time. So 35 here, can I subtract? I get a 4 and I get a 1, bring down my 0. Okay, 35 times what goes into 140? Well, 35 times 2 is 70. And two 70s are in 40. Let's just test that. If I do 35 times 4, oh, look at that. Nice and neat, warm fuzzies. So it's going to go 4 times and we're set. So it turns out that n equals 14. Now, is that what they asked us for? Is it 14 is when they're equal? It says for what number of t-shirts is the cost of two companies equal? Well, we figured that out. So if that's 14, remember n is the number of t-shirts. So the first part for that one part is going to be part of it where we actually can see that the number of t-shirts is going to be 14. But how do I go in and figure out what that cost is going to be? Well, we take the number of shirts and we plug that in to these equations. And let's test it for both just to be sure. So if I come back here for Mighty T, which remember is going to be the cost is equal to 49 plus 14, which is that n. So that would tell me if I do 49 plus 14, it's going to be $63. So the cost would be $63 in this case. Oh man, you guys can't see it again. Shoot. That's what I did. 49 plus 14 equals $63. Let's try that for the other company over here as well too. There's going to be cost is equal to 4.5 times 14. So if I do 4.5 times 14, this is going to be 20, 16, 18. Bring my 0 down. 1 times 5 is 5. 1 times 4 is 4. 0, 8 plus 5 is 13. 1 plus 1 is 2. Plus 4 is 63. Hey, look at that. 63. So both costs are $63. So at 14 shirts, both companies will cost the same at this point. And that explains how we found our answers. So now part B comes along. It says, how can this information be used to decide which plan to choose? Well, if you recall, 14 is the number where they're equal. But remember on the previous part, on part 2, we found out that when it was 12 shirts, that this no shrink was a better deal. It was actually cheaper. $54 is cheaper than 61. But look what happened when we did 20 shirts. Considerable difference. We've got $69 here for this one, and then $90 for this one. That's a big change. So it turns out that that depends upon this 14. 14 shirts is $63, because what that tells us is if I want shirts less than 14, I definitely need to go with no shrink. But if I need more than 14 t-shirts, I need to go to Mighty T because it's a better deal. And that's what they're telling us, and that's why it's useful information. Number 5, explain why the relationship between the cost and the number of t-shirts for each company is linear. How do we know that? Well, if I come back to the actual equations again, remember this is the cost for Mighty is equal to 49 plus n. And the other one was the cost is equal to $4.50 times n, and that's going to be for the no shrink. Remember the structure of the equation we talked about at the very beginning. Remember how from our book they showed us specifically, we're gonna have this setup. We're gonna have some independent variable times a unit rate plus some other starting number. Or it could be reversed either way. So whatever our independent variable is, it's multiplied times some constant rate. In this case, that constant cost for the t-shirts. So you'll see here, in this case, remember, the constant cost for Mighty Tees is $1 per shirt plus that $49. So that will definitely be linear. In this case here, no matter what number of shirts we plug in, it's gonna be $4.50 times that. That is also gonna tell us that they're both gonna be linear because there's a constant rate always being applied. All right, 5b. In each equation, what is the pattern of change between the two variables? That is, by how much does cost change for every 1 unit that n increases? Now that sounds kind of strange, but let's put it more into 7th grade words here. Basically what they're saying is, for every t-shirt I buy or order, what's the change that's gonna occur? Well, in this case, for every additional t-shirt, what's the unit rate here? Remember, it's $1 per shirt. So basically every shirt I order, in addition, it's gonna raise the cost of the shirt by $1 plus $49 for the setup fee. Same thing over here. For every shirt I buy, what that means is if I buy 2, it's gonna be 2 times that. If I buy 10, it's gonna be 10 times that. If I buy 100, it's gonna be 100 times that because the constant rate is $4.50 per shirt. And that is not gonna change in this case. All right, how is the situation similar to the previous 2 problems? Well, thinking back to our work specifically with the line being crossed for the race when it comes to Henri and Emile, remember both of them have consistent rates. You had the walking rate of 2.5 meters per second versus the walking rate of 1 meter per second. In both of those cases, there was a constant rate going on. In these cases here, we have a constant rate going on for the prices of the shirts, and so that is how they are similar. And they're also similar because they're both linear. Part B says the following table represents the costs from another company, the Big T. And here's their table. So for 0 shirts, there's a cost of $34. 3 shirts is gonna be $41.50. 5 shirts is gonna be $46.50. 8 shirts is $54, and 10 shirts is $59. It's kind of an odd table. Now they asked us to do some comparisons here. Let's take a look at what we have. I see they're missing 1 and 2, 4 here, 6 and 7 and 9, and I don't know how that plays into showing the details of this because it doesn't look very consistent. So it's hard to know what the details are. So what I think I want to do is I want to actually change this to a table that has more of a constant flow. Give me just a second to set that up. All right, take a look at what I did here. I actually expanded this table out to be able to go back and fill in the parts that they left out. And I think they did that to try to make it a little tricky for us. But we need to remember the biggest thing that we've been talking about, understanding unit rates. Remember, it's going to be that change of the y over the change of the x, or in this case, the change of the cost over the change of the number of shirts. So what I'm seeing right now in this case, I've made the change specifically by 1, 1, 1, 1, 1. So in here though, I don't know those individual pieces. So I can choose any of these numbers. So how about we do that? Look at the change. If I go from here, from 0 to 3, do you see that? And I go from 34 to $41.50. What's the change in our number? Well, 0 to 3 is going to be 3. So I have here, this change of the number of shirts is 3. And then from here, the change is going to be, wow, 34 to 41.5. That's a tricky one to do. I need to do that on paper. 41.5 minus 34.0. So I'll bring this down. I've got 5. It's going to be 11 minus 4. It's going to be 7. So I have a 7.5. That's my change. So see how I did that? I did 3 minus 0 to get my 3, and my 41.5 minus 34 to get 7.5. That's that change that we see occurring. Now I don't know this. I wouldn't say, oh, I got 7.5 for every 3 shirts. What can we do to figure that out for every single shirt? I would do some more division. So if I do 7.5 divided by 3, 3 goes into 7 2 times. Make sure decimal points are there. 3 now, or bring the 5 down, 3 into 15. It's going to be 5 times And there we go. So this 2.5, that is going to be representative of our unit rate, because I found out that it's going to be the same as 2.5 for 1. So in each of these places now, I need to add 2.5 to that and see if that ends up being correct. So if I have 34 plus 2.5, that would end up being 36.5. 36.5 plus 2.5 would end up being 39. 39 plus 2.5, hey, that works. I got my 41.5. So let's do that again. So 41.5 plus 2.5 is going to end up being $44. Okay, is everybody seeing how this is working? So as we continue through this table, and I'll speed this up for editing purposes in a little bit here, but now I would do 46.5 plus 2.5, and you see I would get my $49. And then I would go to my next one, add 2.5 to $49, and I would get 51.5. Now I'm gonna stop here for a second. I think I just noticed something. Did anybody catch what's going on as I go every 2? So if I go from here to here, how many is that? And from here to here, how many is that? It's actually plus 5 and plus 5. So every time I see that, you see how it's gonna be a plus 5 here. So I could actually realize that 54 plus 5, I'm on the right track. I know I'm right with that pattern there. So I can go ahead and just to confirm this one more time, 54 plus 2.5 is gonna be 56 in that case. So now we can see a little bit more about what's going on. Now, that's a lot of work to go through and sort that piece out. But what can we do for our equation? Well, what's the unit rate? Remember, the unit rate is 2.5 over 1, meaning the cost of one shirt is $2.50. So we have a y-intercept, though, of 0 going in for the number of shirts is going to be $34. So we need both of those pieces. So the cost at big T is going to be equal to that $34 plus the 2.5 times n in that case. And that actually asks us to figure out something a little bit later on, but that's how we can figure out what the equation is. So back to what they actually asked us to do. They actually asked us to do some comparisons for the costs for this company in this case. So what we're now knowing is that the rate per t-shirt is in the middle of both the companies. So we had a $1 per shirt at Mighty T. Now we've got 2.5 for Big T, and we had a 4.5 for No Shrink. For the Y-intercept, or the starting point, the setup fee, we now have $34 here for Big T, but it was $49 for Mighty T, and it was 0 for No Shrink. So it gives us an idea about how these guys, all right. B2, is the relationship between these two variables in this plan linear? If so, what's the pattern of change? Well, if I bring my equation down here, the cost of this is going to be $34 plus 2.5 times n. Remember, for every single shirt I buy, it's going to increase by $2.50. And then no matter what, we're going to be adding $34 to that. So yes, this is linear, because we have that constant rate of change multiplied by our independent variable.